All right, next thing to do here, looks like I already have this written in, so maybe we'll just use this. Okay, theorem. Suppose P is a polynomial of at least degree 1 and C is a real number. So the remainder theorem says when P of X is divided by X minus C, the remainder is P of C. I realize this is in kind of math language and it's hard to understand what we're trying to say, so don't worry. We will look at this in just a second to understand what it's saying and why it is awesome. The factor theorem is the real number C is a 0 of P if and only if X minus C is a factor of P of X. So I think we did kind of talk about that and how we didn't have a remainder on that first problem, and so therefore X minus 2 was a factor of that polynomial, and that was because the remainder was 0, that we knew it was a factor. So the factor theorem is fairly straightforward. Now the remainder theorem is also fairly straightforward if you think about the fact that a 0 is also an x-intercept. It's where y equals 0. So it's a value that's going to make the value of a function 0. Well, that also works for whatever value that function would be with a number that's not necessarily an x-intercept or a 0. So let's look at these. I have this already written out, but I think I will probably clear it out and start over. So I think I've got that on the next page. So if you're trying to copy it, too bad. Here we are. Okay, let's do this. If you need me to go back to those definitions, anyone need me to go back to those definitions? Okay, so step one, we're going to use the remainder theorem. So what the remainder theorem is saying is we now have a new way of plugging in numbers. If we were going to find P of negative 2, and if this did not say use the remainder theorem, what would you do to find P of negative 2? Think back to just your normal algebra skills. What would that mean? Plug it in. So we would have 2 times negative 2 cubed minus 5 times negative 2 plus 3. This would be negative 8, so that would be negative 16, and that would be 10 plus 3, so that would give us a negative 3. There, we found P of negative 2 is negative 3. Not too difficult. We're not bad at doing that. Plug the numbers in, get an answer out, right? Okay, so the remainder theorem is meant to be a shortcut. Watch this. Instead of doing it that way, we're just going to take that negative 2 that we're plugging in, and we're going to make that our divisor. Notice how I didn't change the sign. I'm using the negative 2 as is. I'm going to write down my coefficients, 2, negative 5, 3. Put down the 2. 2 times negative 2 is negative 4. Negative 5 plus negative 4 is negative 9. Negative 9, I feel like I did something wrong. Oh, that's what I did wrong. See, I always need people to learn to speak up and fix my mistakes, because I'm good at those mistakes. Thank you. Did that on purpose to see if you're paying attention. You can pretend that's what I was doing. I'll pretend so I feel better about myself. Okay, so bring that down to 2. So 2 times negative 2 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 2 is positive 8. Negative 5 plus 8 is 3. 3 times negative 2 is negative 6. 3 plus negative 6 is negative 3. Now the reason this is called the remainder theorem, look at the remainder. Synthetic division can be used to plug things in if it's easier, which it would be sometimes. Like, what if you were plugging an 8 into this and you had to cube the 8? calculator and start working on it, right? But if you have synthetic division, chances are you wouldn't have to use the calculator, you'd just be able to rush through it, get it done. So, just a little shortcut, plugging numbers into columns. Kind of cool. Alright, use the fact that x equals 1 is a 0 to factor it, and then find all the other zeros. Now, notice how this is phrased. It's phrased as x equals 1 is a 0. It's not saying, see if x minus 1 is a factor. You have to understand the relationship between factors and zeros, right? So a factor for this would be x minus 1, because the 0 is x equals 1. You see what I'm saying? So you need to understand, with the way the problem is phrased, are you going to change the sign or not? So for this one, when you do synthetic division, are you going to use a 1 or a negative 1? 1, because you use the actual 0. If it's in factored form, then you switch the sign so you're using the 0, right? Just make sure you can do the same types of problems regardless of which form it's given to you. Okay, so we're using 1. And, oh, we're still using the same column with no product. So 2, 0, negative 5, 3. So 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. Lots of 2 in this problem. Negative 5 plus 2 is negative 3. Negative 3 times 1 is negative 3. And 3 plus negative 3 is 0. What if we haven't gotten a 0 there? It wouldn't be a factor, but look at the phrasing of this question. Use the fact that x equals 1 is a 0 to factor. That makes it seem like it has to be a factor. And so, based on the way it's worded. So that means if you don't get that remainder of 0 at the end, you should know that you did something wrong. Or the question is back. I'm trying to trick you. Okay, so that gives us our first factor, we already know is x minus 1. So now we have the factor 2x squared plus 2x minus 3. At this point, we're going to use what we tried to do earlier on the first problem, and it didn't work. And that is, see if we can factor this further using what's left. Now, if we can't, then we're not going to be able to find the zeros by factor. So notice how it says find all of the zeros. We're not finding just the factors. If we were just finding the factors, we might be done because the factors are there, right? But if we're finding the zeros, we know that one of them is 1. But there are 2 zeros associated with this polynomial right here. And you can either find them by factoring and setting those factors equal to 0, or if it doesn't factor, what do we have to use? Quadratic Formula. Gross. Anyway, that's what you might have seen on the screen earlier when I snatched it away from you and didn't let you look at it. But I'm going to go back to it. So here we are with what we did already. And after playing around with 2x squared plus 2x minus 3, we should be able to discover it doesn't factor. So let me kind of explain how you might come to that conclusion. Maybe you try 2 times negative 3, which is negative 6, and you try to think of factors of negative 6 that add up to 2. Well, let's see. We have negative 6 and 1, which would add up to negative 5. Or we could have positive 6 and negative 1, which would add up to positive 5. Or we could have positive 2 and negative 3, which adds up to negative 1, or negative 2 and positive 3, which would add up to a positive 1. None of those add up to 2. So by multiplying the first and last term together and trying to find factors that add up to the middle and not finding them, that tells us it probably doesn't factor, and that's when we use quadratic formula. So we have our quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a So we've got negative 2, so remember this is b right here, plus or minus b squared minus 4 times a times c all over 2 times a. So you can see where those numbers have been plugged in for a, b, and c. Now I think the hardest part of this problem is simplifying. So start with the stuff in the square root. 2 squared is 4, and then 4 times 2 is 8, it's negative 8, times negative 3 is positive 24. So then 4 plus 24 is 28. So you see how we got that square root of 28 by getting those numbers simplified, right? Right there. So 4 squared minus 4 times 2 times negative 3 gave us 28. But 28 can be simplified. 28 is the product of 4 times 7. And 4 is a perfect square. So I did this little thought bubble over here showing, oh, it's not letting me use my, why sometimes switch like this. So I have that all linked together. So here's my little thought bubble over here for my square root of 28. It's 4 times 7, so square root of 4 is 2. That means the square root of 28 is 2 root 7. So that is why I rewrote it like this, right? So then, this other little thought bubble shows how we can simplify it, because both 2 and 2 square root of 7 are divisible by 2, and 4 in the bottom is also divisible by 2. So we take that 2 out of everything and simplify it, and we're left with negative 1 plus or minus the square root of 7 over 2. Okay, so we have 3 zeros because we started with a degree 3 polynomial. I hope you remember that from second grade. We're going to get to that next time. We'll kind of put the cart before the horse. It's called the fundamental theorem of algebra, and that is that a polynomial function has the same number of zeros as its degree. So degree 3 has 3 zeros. 1, 2, 3. You understand why this is 2 different zeros, right? So it's negative 1 plus square root of 7, and negative 1 minus square root of 7. If we wanted actual decimals that we could graph, we would do that as 2 separate columns in a calculator and get 2 different decimals. So 3 zeros. Okay. We're almost done.